It looks like there's about 40 people on the line here, 41. We're starting in just a few minutes. I just want to be sure that everyone is able to hear. Everything is working here from our end, but I want to be sure everything is working from your end. So if you just type in the chat box, not the Q&A, but in the chat box that you can hear us, that would be great. And get started in a few minutes. Thank you. Hello, everyone. Welcome to the MPCA's webinar, Updates to the Minimal Impact Design Standards, or the MIDS Calculator. My name is Ann Gelbman. I work here at the MPCA in the Stormwater Program. And with me this afternoon in the room is Mike Trojan, also with the MPCA, and Mike works in the Stormwater Program with me. And so it's the two of us in a room speaking to all of you who are tuned into this webinar to learn about the Stormwater Manual calculator. So a few housekeeping things here before I turn it over to Mike. Please use the chat box if you have questions. I think as a user you have the option of a Q&A or chat. We ask that you use the chat. I will be monitoring that as we're going through the presentation. We'll try and answer all the questions that do come in through the chat box. I'll try and get to those as soon as we can. Don't get to all the questions. We will go through all the questions after the webinar and we answer them, and all the questions and answers will be posted in Stormwater Manual. There is a page called Stormwater Manual Webinars, and all the recorded version of this and the Q&A and the PowerPoint will be placed on that page in the Stormwater Manual. Hours. 1.5 professional development hours will be offered, and you can access that certificate on the same page, the Stormwater Manual Webinars page. And again, this PowerPoint will be available there. I think it's on there right now. Tentatively, we have plans to do some upcoming webinars or webcasts in May and June. Some of the things we saw from previous surveys that we did a couple of webinars that you may have tuned into, one on filtration, one on harvest and use. We did another one on funding. Some of the things, and we did a survey, so some of the things that we saw in the survey results were people wanted more information on infiltration, biofiltration, calculations, credit pollutant reductions, and so forth. So we're thinking about having future webinars on those topics, so stay tuned. If we do schedule them, I'll be sending out something on GovDelivery and also look in the event section of the Stormwater Manual for information on those. And if you have other topics, let us know what you're interested in. Image of where we'll be posting future webinars. You can see pictures of us, myself, Ann, and Mike Trojan, and there's our contact information, Mike, and a link to the Stormwater Manual, but it's easier if you just go to Google and do a search for Minnesota Stormwater Manual. I am going to now turn it over to Mike.
Thanks. Well, good afternoon, everybody. Middle of the afternoon. No pun intended there.
One thing just before you get started, Mike, I am noticing that there's some people who are saying there's no sound. We are unmuted, so you should be able to hear us. If you don't hear us, well, you can't hear us. So maybe I'll just send a little response to some of the people who are having problems.
Okay, as Ann said in the email she sent announcing this webinar, I'm going to go over the updates to the version 3 now of the MIDS calculator. You have to be a MIDS calculator expert to for this webinar, but presuming you have some familiarity with the calculator, and I'll be getting into the calculator a little bit later, and necessarily showing some of the rudimentary things, but showing you the basic features that we have. So version 3 was released in on January 2nd, and so far we've had about 700 downloads, which is very encouraging. We executed a work order this summer to provide updates to the calculator, and that's the focus of today. Our contractor was Bar Engineering, and Eric Novotny did the heavy lifting for this, and Tim was the project manager on behalf of our. Download the version 3 file, so if you're in the manual, go to the Minimal Impact Design Standards page. You can get at the calculator either at this link called Calculator, or right, for now at least we have this tab, and you can executable file. Else you need to download onto your computer, and then you're able to use the calculator. Well, the topics we're going to cover today are version 2 files and version 3. Infiltration best management practice that was incorporated as a new BMP. Reuse BMP, which is modified from the previous version. I needed called impervious disconnection. We added an iron enhanced sand filter, iron enhanced features of our sand filter, and then there are some other minor go over. So 2 files now into the calculator. Open the calculator, you'll see this option called Import Version 2. You'll want on that. You save the old file to a new version 3 file. And I don't know the answer to this offhand, but I believe it modifies the version 2 file. So if you wanted to save your old version 2 file, I'd really recommend making a copy of that, because I think you'll lose it if you go through this modification process. So if you your new file, go get a coffee. This process may take up to a couple minutes depending on how complex the version 2 file was. Don't do what I did, which was start clicking on a bunch of buttons, wondering what's going on. You have to go through the process again. When it gets done, you'll get this warning that basically says that some new parameters have been added and you may have to modify a parameter or two that you had in your version 2 file. But at the point you now have a new file, version 3 file, and it should populate with pretty much everything that you had in your previous version. Here's on this, so this is the main screen when you come into the calculator. To enter, like before, you'll have to enter a zip code. That provides, here's the zip code. That rainfall information that's needed to provide impervious surface area as before. But you'll have to answer this question. This is a new question. Calculated for compliance with a construction stormwater permit. The reason that question is because if you say yes, you can use the disconnection best management practice because it's not meets qualifications for permit compliance. If you answer no, that particular BMP, which I'll talk about later, used. There are typical defaults: 1.1 inches, which is the MIDS performance goal. Event mean concentration, TSS event means concentration. You can buy those if you want. You get a little flag saying you modify them, but you can go. If you have a 1-inch infiltration standard, for example, you can add that there. This option is not necessary, but you can add more. That's in there. Darn it. I spent the whole 2 minutes putting those new features in, and then I forgot about them. All right. So into the first BMP that we added. It's called underground infiltration. It looks like this on the toolbar, and you'll click and drag it when we go through our example. BMP, because we had a previous BMP called something like infiltration trench, and the storage both within the pipe and in the media, and you couldn't. Previous infiltration trench BMP did not both of those, and so we felt we needed a new best management practice. Any water that's stored below the outflow is going to infiltrate into your underlying soil. Anything above the outflow is considered to bypass system and not getting treatment, whereas 0% treatment for everything below that outflow. I'm going to screen here, and then I'll open up the MIDS calculator and do the sample so you can see deal with it in the calculator. Example that I've got 5 acres of impervious routed to an underground infiltration system. The system consists of 5 half-circle pipes, each 10 feet in diameter, 75 feet long. The pipes sit is 65 feet wide by 100 feet long. There'll be 1 foot of engineered media beneath the pipes. The depth of pipe outflow is 4 feet, and we're on hydrologic soil group A, so it might look like something like this. We've got 5 pipes, 60 feet long, and sitting 30 feet wide in this basin, which is 65 by 100 feet. The pipes are 75 feet long. And then a sectional view, here's the outflow pipe, so anything that's below that is going to infiltrate into this 1 foot, and eventually inline soil. One instance with this best management practice is there are different pipe shapes, half circles, full circles, rectangular pipes, and some of the equations are not necessarily forward. So a couple inputs into the calculator that are actually done outside of the calculator in an Excel spreadsheet. And I'll go to that spreadsheet in a bit here. And this underground pipe storage volume and then engineered media surface area. So to enter those, the calculator is not going to make those calculations for you.
Interrupt you just for a moment because I know I'm seeing on the chat box that some people are not able to hear. I'm not really sure why. Probably one, well, those who are on who can hear, could you just please put something in the chat box so that we can tell that you hope that most of you are able to hear, but some are not? Okay. Some people are having issues, but it sounds like most of you are able to hear, so I'm not quite sure what's happening with the others. So Mike can continue. Sorry about that.
So these are the 2 inputs you need to determine outside of the calculator. The calculator, as we'll see in a minute here, has a link which will take you to the middle and then to the Excel spreadsheet where you can make calculations. What that spreadsheet will look like, circle pipes is going to ask you for a bunch of inputs about the pipe, how many pipes you have, the dimensions of your system, and so forth. And it'll give you the 2 numbers shown here in sand pink, that color is, but these will eventually need to put back into the calculator after you've entered the information into the. So, for example, we can see that we're getting about 17,600 feet of storage in the pipe and the media, so that would be stored above the underground engineer, and then within the engineering media, we're getting another 275 cubic feet for a total of 19,951, which almost meets the performance goal. For example, that's adjacent and the pipes, and that's the underground storage in the media underneath the pipes. All right, go to the calculator now. This is always a dangerous thing to do. See how it goes. Icon for the MIDS calculator. And you'll see when the calculator comes up, and create a new file. Call it webinar. So here's that main screen that I talked about. And the zip code that I'm going to use for this example is 55105. 5 acres, as I mentioned before, copying that example I talked about, and we're going to go no with the compliance because later on I'm going to show how to use that disconnection BM. That would, if I answered yes, that would turn that BMP off. The other defaults just are. So this information, automatic now, and here my BMPs are. And the tracking information on the left, I'm not going to pay much attention to that because I'm just going through an example and the numbers are actually going to, not just you tracking there, but if I was actually working on a site, I'd want to do these numbers for sense. But here, ground BMP, on and drag it on. So that I can either double click or right click to get at best management practice. And 5 acres here, it's BMP by itself, so that's all I need to enter onto this screen and on the parameters tab. And come up with a number for that. Under pipe storage, I need to come up with the number for area if I answer yes, whether there's engineered media. And the way to do that is to go to this link here, information for your pipe. You can order it. But if you want calculation, you click on that link. It'll take manual. Here's the Excel spreadsheet. And here's the spreadsheet. So you can see there's different types of pipes here, full circular pipes, direct pipes, and then have a half circle pipe, so that's the calculations that I'm going to do. Outflow depth was 4 feet, so that distance right here, shown in the static. The intermediate below the pipes is 1 feet. It is 65 feet, I'm sorry, 65 feet. So with the cross basin of 100, if you remember. On options, a pipe radius is 5 feet because these are 10-foot diameter pipes. The length of pipes is 75 feet. Pipes, and put a porosity in of 0.35. You can see the numbers are populated. These are the two numbers you need to carry now back in to the calculator. Calculator numbers in, they were 676. Flow depth is 4 feet again. Media, so I'm going to answer yes. This is my other number, and that's 6,500 for my area of my 1 foot deep. It's number so that I can calculate whether you're going to meet the dry installations here in the calculator. My Q was 0.35. Group soil, hydrologic soil group 8 soils. Drawdown time is 40 hours. And 951 cubic feet. You remember the number I came up with. If I wanted to enter 2 feet of media, for example, I don't meet the drawdown requirement anymore. So that's what that number comes in as a check. I hope. I know this is a little bit complicated to have to go out to this Excel spreadsheet, but we found it was going to be very difficult to deal with all the different pipe dimensions and so forth. And circle calculations are not particularly straightforward either. So one of the reasons why we take use of the
A question that came in?
Yep.
Shouldn't the drawdown time be based on the effective depth?
sure what we're doing is we're calculating the distance it takes for, let me see here, if I can go back. The time it takes for the water to go from below the outfall to, and that, so I'm not sure what effect, and I know effect depth is what's porosity, but porosity is not a factor in considering the drawdown time because we're considering the distance here. You don't have much water here because you're 65% of this media is being taken up by the solid material, but that 35% of water still travel will have 1 foot plus feet here. So the draw time is a function of the vertical distance and porosity. I don't know if that answers the question properly, but porosity affects the volume that you're going to get. If this is all open area, this would be much greater, but you're 35% for pore space.
Even if that did not answer your question, maybe you could put a little more clarification in the chat box. Thanks.
Yeah. Is that so far?
So far.
Okay. All right. Questions along the way, go on, but at this point I'm going to keep moving on. Another question. All right. So, we did have, the previous version, version 2, did have a harvest / cistern best management practice. And we have updated that BMP to a couple new features. We think it's a better, a little bit closer to a little accurate, and allows some more flexibility. These are the 5 main changes from version 2. A little long, and I thought about simple, but I'll read it in layman's terms. But the calculation for water use utilizes a method for determining variable irrigation demand based on potential evapotranspiration from the irrigated area. But just for vegetation type, they were bringing potential evapotranspiration into calculation. Previously, the version of the calculator were only on input from the user as the weekly irrigation rate is. Now, make a calculation based on PET. We also use it to put in weekly irrigation rate. And on A soils, which I'll talk about in a second, unless you're on A soils, you can need the smaller of those 2 numbers. So if you put in irrigating 10 inches a week, you're not inches a week because you're going to be limited by the potential evapotranspiration. The point here, though, is for A soils, we do up to that. We allow users to input rates up to 2 inches a week because there are situations where you may be irrigating for the using water, not necessarily just plant demand. A soils, we felt, could this extra volume of water. I keep staring at the computer like I'm looking at somebody. I guess I got to look at something. So for A soils, you can go to 2 inches per week. July, June, July, your PE is probably at its greatest during the year, and that's going to be about 1.2 inches per gulp. This allow you some extra volume. Water can only be applied if available in storage, and daily irrigation considers precipitation that has fallen on that day. The previous calculator, if on a given day you get any, but if you only had, say, 7 inches of rain and you had water in storage, use that water. So the calculator now allows you to use that water. It could go up to either your specified rate or your potential evapotranspiration. You input a weekly volume retained for non-irrigation uses. It's a big item on our point because not necessarily, if you get for toilet flushing, you're not necessarily keeping the water site. Application was that your table water and not using it to flush toilets, taking recycled rainwater, stormwater, and that water was worth giving the credit for. And I know that's maybe, we've had some discussed that here, and maybe a little bit of a controversial topic, but and we no longer allow March irrigation, which the previous calculator did. Oh, I
think one question did come in. I don't know if it's relevant to right now. Oh, go with display settings.
Where's it?
Up top.
Okay.
Swap. Okay.
Okay.
One question came in. Going off the previous question, is the 48-hour MPCA drawdown requirement time from the outlet pipe invert to the bottom of infiltration BMP, or from high water level to the bottom of BMP?
That's actually a good question. All the water in the underground system has to be out by 48 hours. The draw time is a calculation based on water below the invert of the pipe. Water that's above that pipe also has to be out of there within 8 hours per the requirement, meaning that water has to get out through the outflow pipe. 10 feet of water in there, and you can only get 4 foot of basin. You got to get that other 6 feet out within hours. Basically, you have to have an empty system after 48 hours. It doesn't necessarily have to infiltrate, but it all has to be out of there. I already went through that, but I didn't show up as bullets because I didn't have it. Okay. For the harvest and use, one with the pond being used for irrigation, the other for a cistern. If you're going to use a pond, make sure that you include the pest management practice in schematic. And what you do, and we go through this example, you drop the pond into the schematic, and then you're going to drop your reuse. You're going to route your water to the pond, not to the reuse system. You're going to route your impervious surface to the pond, and then route that water through your reuse system. Assume 1 to 2 feet of available water, so we've got 87,000 cubic feet, 5 acres of impervious surface. We're going to irrigate a 6.5 acre ball field on A soils again. We're going to September. And reminder, since we're on A soils, we could irrigate up to per week. It wouldn't allow us to do that if we were on another soil type. For the schematic, you'll see we've got 2 BMPs here, a pond and MP. We have to populate the pond first. So we're going to put the water to the BMP. 5 acres of impervious surface going to the pond BMP. Without the harvest and use BMP, this is where you would do that, where it says routing to your downstream BMP. And this example. Use your pond design, and for this we're going to choose pond 2. You got it for a pond increased phosphorus and TSS. You're going to input the volume. Just reminder not to route any water runoff to the BMP. Irrigation application area here. I'll go through all of these. These are all the BMP inputs that you're going to need. Where you have the system go offline during the off season. The annual volume calculations need to be a little bit off. Otherwise, if you keep the system to the winter. Irrigation water here, and so that when we get to the cistern example, after the example here. I'm going to calculator. I'm going to close this other BMP. Or right here, I can get rid of that other BMP, which I'm going to do here. And harvest and use BMP is down here. Tag it is right here, and you click that there. I'm going to, because that's more visibly appealing to me. Again, click or double click on the pond BMP. So I've got 5 acres. I'm going to here, it's not necessary, but and here I'm going to route downstream, I'm going to route this water to my house and use. Best method practice. BMP tab, I click on, and I have to pick here. You'll see here now that there's no phosphorus so far, but if I choose level 2, enough in. And so you're going to get the extra treatment when you route this to your pond BMP rather than directly to your harvest and use system. So okay, and now that the water is being routed, one BMP to the other. Click on this. I'm not going to route any water here because all the water is coming from the upstream BMP. Important if you put 5 acres in here again, now you've got 10 acres impervious, which is not correct modeling this system. So the inputs, and those were, so I look at my cheat sheet here, 87,120, lots of water. We're going to irrigate 6.5 acres. You can put right here. We're going to a week. And that's we're going to. One thing you notice is that we're asking the vegetation type. There are some calculations behind here for different types of vegetation. So you get a better credit on vegetables, I believe, versus something. I don't remember the exact numbers, but you can manual and get that technical information if you need to. We're going to be meeting in May. We're going to September. Why that keeps popping up. But this, we are not going to use water on site for non-irrigation. But the pond, there's plenty of water in the pond irrigation needs. The total volume ends up being 1913 cubic feet. You'll see that achieved irrigation application rate is 1.9 inches. I'm not quite sure why that isn't quite 2. But back here, you see it's 19,213. If I was to go back here in soil, that number it does all the way down to 11,000 because we can no longer, even though I put in 2 inches, it's not going to let me do that. That'd be soil. So defaulting back, and you can see that the average irrigation rate is 1.11 inches per week to what we had with 2 inches per week. So difference there between those two. As you can go in and look at the BMP summary for any best management practice that you're in, it will provide you with a summary, show you volume removal, how close you are to meeting the performance goal, which is we're 96% of the way there, and volume, or in particular phosphorus removal and so forth. Dissolved phosphorus, yes, I think, is at the bottom. Yeah. And if you had multiple BMPs, you could go into the results page here. So this is your summary for the entire In case we do have 2 BMPs, and it would show you how each piece is performing. Back, and we're going to maximize this. So we're going to do that.
That first
Excuse me. Now I'm going to have a cistern. Insert rough to direct to a cistern. And I am going to irrigate a ball field, but use some water for non-irrigation purposes. I'm going to assume I have a 30,000 gallon tank capturing 1 acre of rough. It's a big rough. Irrigate ball field. Excuse me. This is from May to September. Again, soils, and we're going to take a credit for non-irrigation purposes.
with the water.
So we'll go into the calculator in a second, and you'll see where I put all these in. And for now, I'm not retaining error. If I know there, I can't achieve my performance goal. You see that I'm at, what's that, about 2,500 or something?
2956.
2056, and I need to get to 993, so I can't get there. I could get there if I increase the application area, but they have 1 acre of ball field. I can't do it, so I use purposes and make some assumptions. So let's just assume this is a stadium where we've got 7,000 people coming in for a game. In the toilet once, 2 gallons per flush. I know that an Iowa game is about 7 flushes per person per game. But let's just assume it's 3 games per week. And I came up with that number there. And simply the volume credit is limited by the size of the cistern. You can see with the pond system, this is not going to make much difference. Calculation, but if you have a cistern with a limited volume space, you may need, which you can maybe get through non-irrigation purposes. Like I said, you could increase your application area in the second here, and that would get you to your performance goal too. And we'll just modify this. So in this case, we have about 1 acre of rooftop. Number. We're not going anywhere with the water. This is 1 acre of impervious going to this BMP. I have used it from the previous calculation, so I have 4,000 cubic feet of storage in my cistern. With 1 acre. Yes, because I'm going to put 2 inches of water on 8. This is the same. If the system goes offline, it's run from May to September. It's on turf. You can see again, if I don't use irrigation purposes, I'm not going to get my performance goal. I get 2956 versus 993. Change this, and now I'm going to use water for toilet flushing. And there was 615, and obviously that's going to get us to our performance goal of 3. Now here, and we can change this number to say 2 acres. Performance goal. If I turn, it's performance goal too. U-turn versus a pond, it's much more sensitive to the amount of water that's available in that system.
We did. Just want to
Go back to part.
go back to PowerPoint.
Okay.
And Okay, so we did get another question from Jeremy, and he says it's related to the previous question about the 48-hour drawdown. He said, if all the water was drained in 48 hours from water elevation, one event must be used. 100-year, 10-year, 2-year, at a point in the storm. A 24-hour storm, 48 hours start at 0, 12 hours, or 24 hours, or a peak elevation. And
Answer parts of it, and part of it I can't answer, and I think the best on this question, because it is a complicated question, the part I can answer is the part of the farm, that's up to the person, that's the people design the system, what farm you want to design it for. There within 48 hours before the next storm, but the rest of that question, I think it's probably best that I sit down with our engineers and talk to them, and we probably will, then we'll post the answer to this. I apologize for not getting to it right away, but give out any bad information, at least more so than usual.
we'll be sure and get the Q&A posted probably by Monday for sure.
Okay. So, a question for our engineers. Deal with these types of things more and more permit, and accept the language in the permit and still annoyances with the language in the permit. So I say something that's incorrect to that, but we will post the answer to this question online.
That was it.
Okay. Question. How's that for avoiding questions? Right. I don't think any of them are listening.
There is.
They haven't responded yet?
At least one.
Okay. So, BMP. We went to the calculator. It's the impervious disconnection best management practice. And you can see that right here on the icon tab, right, like that over. You can divert runoff from an impervious surface to a pervious surface. For example, from a parking lot to turf, a roof to lawn, or whatever it happens to be. This cannot be used for construction stormwater permit compliance. So way back in your webinar, you remember you have to answer that question whether you're using it for permit compliance or not. And if yes, you will not be able to use this being essentially turned off. Calculations are based on some swim modeling that was done as part of the MIDS 4 years ago, which they were looking at the effects of improving turf routing, improving to this best management practice. Enter the amount of impervious area that you're routing to an active pervious area. Important to note, though, that your impervious area cannot be any wider than 100 feet, because since the channeling begins to start 100 foot. Water moves 100 feet, you start to get channeling out here. You no longer really have an effective pervious area. Then the soil type, and then this basically looks at some percentages that were developed as part of the swim modeling and pick appropriate numbers and the returns of the reduction capacity of that management practice. Pervious area routed to the pervious area, which is limited to 100 feet. Area cannot exceed your impervious. And you need here. We're impervious to 1 acre of pervious surface. With 2 examples, A and B soil. Just differences in the results of those. You see that here infiltration on the A soil is about 2,800 cubic feet compared to about 2,100 some cubic feet on the B soil. So you're getting more infiltration on A soil, which you would expect. But in neither case are we meeting the performance goal for this practice. And that's partly because if it's raining, we're already raining and dropping water on this affected person. So we're adding additional water on top of that. And so it's difficult to infiltrate that volume of water and meet the performance goal. To the calculator. I'll get rid of the MP. This is BMP to the screen. Double click to open it up. Here I need to enter the pervious because this is where it's going. So I need to enter that here in 1 acre. This be self again, so we're not routing anything anymore. You can change the names of your BMPs if you want here. Routing somewhere else. Parameters tab. Acre. So 43,560 square feet to 1 acre of pervious, 43,560. And we're going to do that on A soil. That 100 cubic feet. Now get to the performance goal.
Okay, question came in. I think it's relevant right now. Is this impervious disconnection have to 100% disconnection? Do you want to answer that?
I don't know what that means. It's you're taking an impervious area that you know and route this pervious surface. So if you have a 5 acre, only route 1 acre of that 5 acre parking lot onto the pervious surface, then your corrected impervious would be the 1 acre, not the full 5 acre impervious parking lot. I don't know.
And then he goes on to say that SWIM 5 allows user to choose the level of disconnection from 1% to 100%.
Yeah, that's the layer feature. So I hope what I said, so if I'm understanding the question right, when not probably not because I usually miss these things. You've got a 5 acre parking lot. Some you were in 10 route 1 acre of that 5 acres to their impervious area. I don't know if that's my correct interpretation. Here it's just asking for what your expected impervious area is. It's not asking for your impervious area. Guess maybe this parking lot acres here. And you route 1 acre of that to a pervious area. Now you can see your performance goals really jumped up, as you expect, close to 20,000 cubic feet. You're getting the same amount off of this BMP. So in this situation, you'd have to find a way to treat that other 4 acres plus the additional volume that's heading towards the performance goal here. So that's just a question.
Yeah, and Jeff asked that question, and if you if we're not answering your question, all you just said is a correct assumption. So okay. I think we're good. Okay. If not, use another message.
What we would do, and we might do in this situation, okay, so what I've done is I've changed this to acres now. This is different than example, but I'll just stay on this for a minute. So having 5 acres, so to only the 1 acre of impervious, or to 1 acre of pervious, this might be a situation where I might then route this to an iron filtration system, that BMP maybe. So I'm getting partial treatment, BMP, and routing left over to this other BMP. And maybe one of the flaws with this webinar is I'm focusing on these individual BMPs. I'm not talking about any treatment trains, so it would have been a good idea to have an example with multiple BMPs. If there's time, I could clean up, although it's always dangerous to think and do things on the line. So that's the example maybe he was getting at. So this, so real quickly, quicker example that I was using. $39.93 for our performance goal, and with the A soil we're getting like over about 5% of the way there, whatever. And if the soil it's 23, considerably less. And the sea soil, I get even less. Down 95. So not much of a drop there as I might have expected. BMP again, just a reminder about what restriction here.
Okay. From Tom Schuler, for all of those of you who are listening to me, because it's all about me, this to get you back focused on what we do, which is to with this webinar. It's Tom Schuler for that little trick that works or not. Teaching, and I found as a trick that works in classes. After the classes to say, time for a pop quiz, and everybody seems to get wet. So we're more than halfway through, so that's appropriate, I think.
Another modification we did was to add an iron enhancement, the enhanced sand treatment filter. We have sand filter, where is it? Right there. We did in the previous version of the calculator, but we did a version of the calculator, but got treatment for particulate phosphorus. There was no for dissolved phosphorus. And so we're allowing the option to put in an iron enhancement. And I think it's amendment. I'll have to look at the language when I open the calculator. So previous sand filter, but it asks if you're adding an amendment to attenuate phosphorus. So I think the slide is actually mislabeled. It should be amendment to attenuate phosphorus. So 1 acre of impervious surface draining to a sand filter. It's not needed because this is not a volume reduction best management practice. You're only getting treatment for and total suspended solids. And meant to treat the iron, you're going to get a 40% credit on phosphorus versus no credit with no. You can see that here. There is no amendment. You're not all phosphorus treatment. If you get a 40% credit for the dissolved fraction. And middling of the previous slide, it's iron amendment, and this is indicator. It just asks you if you're adding an amendment. If you go and get a 60% credit for an iron enhanced sand filter instead of 40%, so in somewhat of disagreement with the manual right now, which is giving other credit because the manual is based on iron. And our other amendments of to discuss in the manual, and I'm sure elsewhere in the literature. So right now, that's the reason why we've kind of backed off and are only 40% credit Our research scientist, David Fairburn, is working with a number of folks on a lot of these systems in place out there now, trying to determine whether or not the credit is appropriate or whether it should be, in theory, this credit should actually be higher, but the systems aren't performing, a lot of systems aren't performing the way we thought they were going to, and it has to do with just operation and maintenance rather than the theory, because in theory the numbers should be higher. But for a second, and later. Okay, SPP, I don't have to get rid of it, but onto my sand filter here, I can drag that on. The calculator does not require sizing because it's not a volume reducing best management practice. 1 acre going to this, I'll go to the BMP parameters tab, and the only thing you have to answer there is whether or not you're adding an amendment. And say no. You get a yes. Credit. Pretty forward. Sheet here, and in a minute here, I'll take you to some of the help functions in the calculator if you're not familiar with those. All right. In the calculator, these.
It's like, pay close attention to this slide.
Yeah. For those of you who know me, you probably get it. Those of you who don't know me are probably going, what the hell is he doing?
I get it at first. You just have to pay attention to figure 0 and just keep going.
For those of us who have been exposed to male pattern baldness to the life change that you have to go through. And in your life, you just accept it. The old boy that gets on the bus with me in the morning, and he asked me one time why I don't have any hair on my head, and I said, well, that's why I have hair on my face. Anyways, there are a number of other changes in the calculator that I'm just going to go over briefly. I'm going to go into the calculator to show these, but they're pretty straightforward, hopefully fairly self-explanatory. Of the calculator, if you raise the under drain above, it only gave you credit for water stored below the drain. If you put it at the bottom, it gave you credit for water infiltrating through the bottom. And what I recognized was that you raised the under drain and actually reduced your infiltration because you lost the credit for water infiltrating through the bottom. So corrected the calculator so that the under drain, you get credit for the water below that under drain, as well as seeping into the under drain while this drains down. And so down here, you can see this volume reduction below, as well as from infiltration out bottom on the side of the practice. So, huge number, but it's a number, and once you get towards your performance goal, if you're on C down. Use those props and putting in, I'm not going to use them. Permeable pavement with an under drain. You're asking the question now, are you soil? If you answer no, keep the infiltration rate for D-soil, which was in the calculator before, which is 0.06. So this thing is draining, you're getting 0.06 inches per hour drainage through the bottom. Answer yes to this question, we reduce it to 0.03 inches per hour. Some compaction in your system and reduce the infiltration rate. At least that's the assumption. Again, it's going to be a big number. These are pretty low infiltration rates. may make a difference. Our retention base, I'm not sure why the picture isn't showing up here, but it used to be that if you had a bioretention base, it assumed that the entire swale was underlying and had some base under it. That may not be true, so we're asking you, is the swale underlain by a bioretention base? And if it is, well, you get credit for having a bioretention base under the entire system. You're going to get in storage through that. But if part of your system, if you're only for that part of the bioretention system that has that retention, the swale system, I'm sorry, you're only credit for that part of the swale that by the bioretention system. Media depth to 3 feet. We previously didn't limit the media depth. You could put in some astronomical numbers here and get funny results. So we'll limit that media depth to 3 feet. Bioretention BMPs, we change particulate phosphorus credit from 45 to 80% for soil mix C or D or low soil phosphorus content. Just simply a mistake in the previous version. It's not based on any new data or revelations. It was just an error in the previous. Those of you who aren't familiar with this, C or D or low phosphorus content, is 100 grain in your system, and soil mix A or B, both of which have high organic matter concentrations, showing that these systems are actually leaching phosphorus. And so you're not going to get any credit unless you have low phosphorus concentration in your soil. So you have low organic matter contents, and so they're assumed to not leach phosphorus because they're assumed to have a low phosphorus concentration. So we mixes, and those don't show up in the calculator time. That'd probably be something we with next iteration, which probably way off in the future. Yeah. That the MIDS calculator was compatible with Excel 2000, and with an underdrain. If you have a raised underdrain, it doesn't make any sense to raise an underdrain and then put a liner into your bioretention base. Just attempt to reduce. Free is Windows 10 compliant. We made sure of that. Where can I and guys, you can contact me if you want an answer, but if you want an answer, or use the help button. And those are shown here, and I'll actually go into the calculator and show where you can get through those. Let's go ahead and use one we've got. Help, and it should take me to the manual, take me to a page. So I was sand filter, if you remember, I had the sand filter BMP up. So let's take to a page called Requirements, Recommendations, and Information for Using the Sand Filter at the end of this calculator. User inputs that you need. It'll just count what it have, and I'll give an example. Right now, most of the examples on these pages are version 2. We'll probably update that over time. We did update, so I'll go back here real quick. Out of this, I'll bring back this underground. If I go here, what do I do?
Okay.
Okay. Click on Help. It'll take you to a page recommendations for using underground infiltration. Same here. Calculator inputs. for the different options in the calculator. The model recommendations, calculations, so you can see what we're doing, how up with the numbers. See that for those new fees, we actually do have version 3 examples in here. And it takes you to some of the screenshots in the example. I don't believe this example matches the one that we used in the webinar, but it's pretty straightforward. And you can see there. I think if I go back here, yep, that just takes you to that page. I think that takes you to, oh, the page, okay. Look at those links. If you're struggling, look for the help button or the links that you're in. If you want to get manual and get. You can links to all those pages on this page called Links to Manual, Links to Address the MIDS Calculator, and you can see that all these are there. In fact, I'll go ahead and click on that. Go in and see that all those recommendation pages are here for bioretention, biointegration, biofiltration, and green roof, and so forth and so on. I already went to the page, so what it looks like. Hover over page contents. Oops. Oh, to see page contents. If you hover over that, it'll tell you it'll give you a table of contents for the page, and you can click on any of those and get the particular part of that page in the manual. There is a point.
I'm not seeing anything in the chat box. If anyone has any questions about what Mike just went over, please send a message in the chat box and we'll do our answer.
You all think questions or not is into creating instructional video YouTubes. Basically, they tend to be a half hour in length. Videos intended to focus on a specific topic, not necessarily just the MIDS calculator, but I think that would be a good place to start with some of these instructional videos if we're able to make that happen. So keep your eyes open to that announcement. Hopefully, if I get an answer to that in the next day or two, and if we can start putting those instructional videos together and getting those on into the manual.
Yeah, webinars like we're doing now, but we would just record them and then play manual. But we do have the technology to do that and are able to. We will let you know. There are a couple. All right. Jessica wants to know, for underground infiltration systems, what is acceptable to get your volume, your outlet, and your media surface and directly from your HydroCAD model?
Yes. Yep, emphasize that. And if you go into the manual, it'll say that basically, that you can use that spreadsheet to get the volume. You may have information from the device that you bought, or from some other modeling, HydroCAD, whatever it be. So you just need to come up with that number in defensible fashion, whatever that happens to be. We built an Excel spreadsheet to just one tool that people can use to get at those numbers.
Another in here, this connection BMP cannot be applied for compliance with permit because it cannot capture an instantaneous volume. However, this type of BMP seems as though it would perform or to a swale side slope, oil with no check dam. Could explain further.
We've been here internally, and I agree with you. It was made at some point in the past that swales were given a credit. They were part of the MIDS process, and I think you make a argument why the other, and it's just, I guess, just an arbitrary decision that we made. You don't get a lot of credit, I don't believe, for swales if you direct them or about retention, but there's credit there. So, yeah.
We elaborate on that a little more with our engineers, possibly.
Yeah, probably already got Mike on my side here.
Here that swales are very hard to protect as an infiltration practice during construction. Yeah, swales are very hard to protect as an infiltration practice during construction.
Okay. Maybe a note too that we are going to update the swale section in the manual in the coming months. We're in the process of writing a work order. We realize it hasn't been updated since the original manual in 2005, and I think that there's a lot of new information out there. So hope to have that in the manual by the end of the year.
Here, why are BMPs used to satisfy CSW permit excluded from these calculations? Sure. Why are BMPs used to satisfy CSW permit excluded from these calculations? I'm not sure I understand that either. Noah, if you could clarify that a little better.
Yeah. Example, that would be helpful.
Yeah. We're on your question. Any questions that people have? We've had your people on webinars, so that's great that we're seeing so much interest in the UpMIDS calculator.
As long as we got some folks online, I know we're hoping to put tutorials together. We've had questions about workshops. We have limited resources, can't do a lot of them, but we have talked about getting out in workshops on the MIDS calculator. If there's interest in that, let us. You can either do it through the chat box or emailing us or whatever. But just in the workshops, which I think are hands-on, where we actually get out and can people in our groups, probably 15 to 20, that have been smaller, 10 to 15. I think that would be useful to you.
Noah did clarify that question. He said, you mentioned earlier that if BMPs are used to satisfy the construction stormwater permit, the calculator defaults to exclude them from the treatment calculations.
I remember saying that. I don't.
I can take this offline, and if you want to send me an email and the phone number, we can with you.
Yeah, I don't. If I said that, that's not correct. I mean to imply that if I was talking about the impervious surface disconnection one.
Oh, talking about disconnected impervious at the time.
Yeah, that BMP is not available for water permit compliance because it doesn't capture the instantaneous volume. That BMP, because I had a lot of
people approached me asking me about that BMP, not with respect to permit compliance, but with respect to TM compliance. I guess that's a permit compliance issue too. So that is actually inserted more for its pollution reduction ability than its volume reduction. You do get volume credit for it, but you'll probably be able to achieve your performance goal with that. And when that was done as part of the MIT, so we did use that to get volume credit, but really BMP was primarily brought into the calculator for reduction credits. And then maybe I should have focused a little bit more on those pollution reduction credits when I showed that practical. If you go into the calculator, look at phosphorus and TSS, because that really kind of was, I think, the focus of that.
Okay, we're getting a couple people that are volunteering to host workshops in their area, and that's really great. We'll be in touch with you. A couple other people are asking that they'd like to get the PowerPoint file. That's actually available in the Stormwater Manual right now. If you go to the manual, to the table of contents, I'm pulling it up right now. Table of contents, and roll down to Communications and Outreach, Stormwater Manual Webinars, and where you're going to find the recorded webinar, probably tomorrow if I get it. But PowerPoint file, Mike is highlighting right there. And the PDHs are there too, right above the PowerPoint.
And the recording will be here too whenever we get around.
Yep.
Be here too. If you go to the previous webinars, we do post those.
All right. Any other questions coming in? And
Some other questions?
no, I don't see any other questions, and people are starting to drop off.
Okay, so
PDHs will be. Mike showed you that. So questions, I think. Last slide, Mike.
we get class early today.
Yay! All right. Hey, thanks everyone for tuning in, and get those PDHs, and we'll be sending you further information. Thank you very much.
Have a good day.